Good morning to all. I'm Sumitra, working as an associate professor in AAA Department of R&D Engineering College. And this semester, I'm handling renewable energy system for semester AAA students. And now, in this video, I'm going to give introduction regarding the solar cell and the process happening in the solar cell in order to come out with the electricity production. So regarding solar cell, we all know that it is a photovoltaic device which is converting the light energy absorbed from the sun into the electrical energy. And also this is working on the principle of photovoltaic effect. And how means the generation of the voltage across the PN junction, which is happening in a semiconductor, is due to the absorption of the light radiation, which is nothing but a photovoltaic effect. So here we have types of solar cells based on the crystals used for constructing the cell, namely the monocrystalline silicon cell, polycrystalline silicon cell, and amorphous silicon cell. So coming to the monocrystalline silicon cell, here this solar cell, solar cell is constructed by using silicon in its pure form, and it is defect free. And comparatively, the efficiency of this cell will be higher than the other two constructions. So in polycrystalline solar cell, we'll be going for liquid silicon instead of a crystal one. So liquid silicon is used as a raw material and polycrystalline silicon was obtained, followed by the solidification process. First, we'll be taking the liquid silicon as a raw material. Then by going with the solidification process, we can able to get the polycrystalline silicon cells. And the efficiency of this type of cell is obviously less than that of the monocrystalline one. And coming to the last step called the amorphous silicon cell, it is just obtained by depositing the silicon film on a substrate like a glass plate. And the plate thickness will be about 1 micrometer, less than 1 micrometer, and the thickness is resembling a comparison with that of the human hair about 50 to 100 micrometer. And this efficiency of the amorphous cell is much lower than the other two types of cell. So these will be widely used only in the low power equipment like the packet calculators or the watches, which are used in our day-to-day life. And this table will show you the comparison of the different types of solar cell with the aspect of efficiency. Among the three types, monocrystalline silicon is said to have higher efficiency percentage in the range of 14 to 17, whereas the polycrystalline silicon is said to have an efficiency between 13 to 15, and amorphous silicon is said to have an efficiency between 5 to 7 percentage. And then regarding the advantages, we all know that it is resulting in a clean and non-polluting environment as it is a renewable energy and it doesn't produce any noise. And then it also requires very less maintenance. And comparatively, this is said to have a long lifetime and it doesn't require any fuel cost or fuel supply also. Next, this diagram will show you what is a solar module and how a module can be constructed and how a panel can be constructed with the help of the module. So here in this diagram, these are all the solar cells and these solar cells can be either arranged in series or parallel in order to form a module, and these modules can be combined with number of modules to get a panel. This is how the solar panel will be. Now, why I need to go for this solar photovoltaic system is because it is said to have a lot of advantages. That is minimum maintenance and maximum reliability. That is, we can able to expand this solar power plant if in future we are in need of more output. So that is easy expandability is possible, and minimum maintenance is required, and energy independence. And depending upon the requirements, we can also go with different types of solar cells just by adding a number of cells or panels in series or parallel. So when the solar panels are connected in parallel, then we all know that in parallel the current is getting deferred, but the voltages will remain same. So this schematic diagram will show you how the arrays are getting connected in parallel. So if the single panel is having a capacity of 6 volts per 3 amps, then the output of the entire panel is 9 amps and 6 volts. And this diagram will show you how the panels are getting connected in series. So we all know that in series connection, voltages will be getting in added form but the current is going to remain the same. So if you consider the same rating of a PV panel as 6 volt and 3 amps, at the final output, that is the total output of the entire panel after having 3 panels in series will be 21 volts 3 amps. Next comes the advantages, and here it converts the solar energy directly into the electrical energy, and these systems are reliable, durable, and maintenance free, and it can be located at the place, any place. It doesn't involve any distribution network. At the same time, it is having certain drawbacks, like the efficiency of the solar cells are very low. We are in need to connect large number of solar cells in order to generate more power. As the solar energy is intermittent, that is, it is available only during the daytime. So in order to supply the load during the night time, we need to go for some storage devices, nothing but a battery, which makes the system more expensive. And this will show you the principle of solar cell. As I mentioned earlier, it is operating on photovoltaic effect. And when a PN junction diode is formed by means of silicon, then if light falls on that, photons, that is, photons falls on that, then it will excite an electron from the valence band to the conduction band, leaving an equal number of holes behind, and in the depletion region moves in opposite direction toward and this solar open circuit voltage is the one which